Hi, Chapter 7 is all about expressions, and so we're going to begin this tutorial by looking at how expressions appear in our textbooks. An expression does not have an equal sign, but it does have a lot of good stuff to it. There's always going to be a variable if it makes it an algebraic expression. If there is no variable, you would call that a numeric expression. It will always have an operation, and it will always have a constant or a number. For this problem, the algebraic expression is 2a plus 13. There are two operations going on in this problem. The addition sign, which is pretty obvious, but then also the 2a represents a particular operation. When a number is right next to a letter or a variable, it means to multiply. Right now, if we were just looking at 2a plus 13, we cannot solve that expression because we don't know the value of a. However, if you're looking off to the side, it does say that a is going to represent the number 4. In order to solve this, we're going to apply the plug-in-chug method. That means we're going to take the value of a and plug it right in to where a is found in the equation. When I rewrite it, we have to keep in mind that that 2a represented multiplication. If you don't put a time sign, it kind of looks like 24, and that's a big no-no. So I'm going to put my multiplication sign there, and now I've just plugged in the value for a. Now I'm going to solve it using my order of operation rules, and that means multiplication will be done first. 2 times 4 is 8, but I still have to add 13. So the last step to my problem is to add those for a grand total of 21. Let's try this again with a slightly more complicated problem. N to the second power over 4. Okay, so now what we're going to do is we're going to have to be given a couple values. And I forgot I'm going to subtract m, by the way. So our first value is going to be n is equal to 1. Let me just change colors here. So n is going to be equal to 1, and then our m will be equal to 0. So now that there's two variables, we're going to have to plug in two different values for those variables. Where I see an n, I'm going to put a 1. Rewrite everything else down. And when I see the m, I'm going to replace it with a 0. According to my order of operations, I see an exponent, a division sign, and a subtraction sign. And I have to do my exponents first. So that would be solving that numerator, or the 1 to the second power. 1 to the second power is the same as 1 over 4, and then I'm going to subtract 0. You could treat the division problem as a fraction and just leave it as 1/4 minus 0, and then the answer is going to be 1/4. If you really wanted to do the division problem, sure, 1 divided by 4 is 0.25. Then that final answer, minus 0, is going to remain the same, 0.25. Let's try one more problem and see what we come up with. Let's have a 5x squared minus 3y. X is going to equal 4. Y is going to equal 2. So here we go again. Right now we cannot solve this algebraic expression because you don't know the value of x and y until you look off to the side and you are given the values. So these are expressions, not equations. So when we plug in these values, 4 to the second power, minus 3, 2, some stuff kind of looks weird. Hopefully, you're yelling at the computer saying, wait, you forgot your multiplication signs, which makes a huge difference. So now that we can see this awesome order of operations problem, the first convention, or correct process, will be calculating your exponents. 4 to the second power is 16, because 4 times 4 is 16. I'm going to rewrite everything else down. From left to right, I'm going to solve the first multiplication problem. So 5 times 16 is 90. Rewrite everything else down. Still on that multiplication part of that triangular pyramid we've been talking about in class. 3 times 2 is 6. And wrap this up. Our final answer is 84. So thank you for watching the video on Chapter 7, which is all about expressions. I hope this helped somewhat. If it doesn't, please come talk to your teacher. Thank you.